Antikythera Mechanism. The Antikythera Mechanism looks, at first, like a corroded lump of bronze. But inside those broken fragments was one of the most astonishing machines ever recovered from the ancient world. It was found in 1901 in a shipwreck near the Greek island of Antikythera. For decades, researchers struggled to understand what they were looking at. Then X-ray imaging revealed something extraordinary, a complex system of bronze gears, dials, and inscriptions. This was not decoration. It was a working astronomical calculator. The device could display cycles of the sun and moon, predict eclipses, and track calendar cycles. A 2006 Nature study described it as a unique Greek-geared device from around the end of the 2nd century BC that calculated and displayed astronomical information. It is often called the oldest known analog computer. The mystery is not simply that it existed. The mystery is how advanced it was. Nothing with similar known mechanical complexity appears again in Europe for many centuries. It suggests that ancient Greek engineering may have been far more sophisticated than the surviving record shows. The Antikythera Mechanism feels like a machine dropped out of the wrong century. It did not move armies or lift stones. It moved time, sky, and prediction through gears small enough to fit inside a box. Hero's Aeolipile. Long before modern steam engines transformed the world, Hero of Alexandria described a device that spun using steam. The Aeolipile was simple in concept but astonishing in implication. Water was heated, steam traveled into a hollow sphere, and jets of escaping vapor caused the sphere to rotate. It was not an industrial engine in the modern sense. It did not power factories, trains, or machines. But it showed that ancient engineers understood something powerful. Steam could create motion. Hero lived in Roman Egypt in the 1st century AD and was associated with a range of mechanical inventions, including steam-powered devices, automatic doors, and vending machine-like mechanisms. The Aeolipile is mysterious because it raises an impossible-sounding question. If people had already seen steam turn a machine, why did the steam age not begin nearly 2,000 years earlier? The answer is probably practical. Ancient economies, materials, fuel systems, and labor structures did not create the same pressure to develop steam power into industry. Still, the device feels haunting. It was a glimpse of the future, spinning quietly in the ancient world without starting the revolution it seemed to promise. Hero's automatic temple doors. In some ancient temples, wonder could be engineered. Hero of Alexandria described a system in which temple doors opened automatically after a fire was lit on an altar. To worshippers, it may have looked like divine power responding to ritual. In reality, it was a clever arrangement of heat, air pressure, water, weights, and pulleys. Fire warmed air inside a sealed vessel. Pressure moved water. The shifting weight activated the mechanism, and the doors opened. This was not magic, but it was designed to feel like magic. Hero's automatic doors show how ancient machines could shape emotion as much as function. The purpose was not transportation or industry. It was theater, religion, and authority. A machine hidden behind sacred architecture could make a ceremony feel alive. Sources describing Hero's temple door mechanism explain that it used a fire, altar, and hydraulic system to open the doors automatically. This machine is mysterious because it blurs the line between engineering and illusion. Ancient inventors were not only solving mechanical problems, they were building experiences. A worshipper saw a miracle. The engineer saw pressure and motion. The temple stood between both worlds. Zhang Heng's Seismoscope. In AD 132, Chinese polymath Zhang Heng presented a device to the Heng court that seemed almost impossible for its time. A machine designed to detect the direction of distant earthquakes. Historical descriptions say the Seismoscope was shaped like a bronze vessel with dragons around it. Each dragon held a ball in its mouth, and below them were toads waiting to catch the falling balls. When an earthquake occurred, the device would drop a ball from one dragon, indicating the direction from which the tremor had come. According to accounts in the Book of Later Han, the machine once signaled an earthquake, even though no one in the capital felt anything. Days later, a messenger arrived reporting that an earthquake had occurred in the direction the machine indicated. The device is commonly described as the first known seismoscope, though modern reconstructions and explanations remain debated. The disturbing elegance of this machine is that it tried to make the invisible visible. Earthquakes happen underground, far away, without warning. Zhang Heng's device turned hidden motion into a signal. Even today, the exact internal mechanism is not known with certainty. That uncertainty gives the seismoscope its power. We know enough to admire it, but not enough to fully rebuild the moment of genius that made it work. The South-Pointing Chariot. The South-Pointing Chariot was not a compass in the ordinary sense. It did not depend on magnetism. Instead, it was a mechanical direction keeper. Ancient Chinese sources describe a vehicle with a figure mounted on top, always pointing south after being set at the beginning of a journey. The first reliably documented version is often associated with Ma Jun in the 3rd century AD, though legends claim earlier examples. No original machine survives, and scholars debate exactly how different versions worked. The idea is brilliant. As the wheels turned and the vehicle changed direction, gears adjusted the pointing figure to compensate for the turn. Some modern reconstructions use differential gearing, similar in concept to mechanisms later used in automobiles. Though ancient designs may not all have used the same system, its mystery comes from the fact that it solved a navigation problem mechanically. It did not ask where south was after every turn. It remembered the original direction through motion. The South-Pointing Chariot feels like a machine that thinks in wheels. It did not calculate with numbers, but it converted movement into orientation. For an ancient traveler, that must have seemed almost supernatural. A wooden figure calmly pointing south while the road twisted beneath it. Archimedes Claw. During the Roman siege of Syracuse in the 3rd century BC, ancient writers described terrifying machines designed by Archimedes to defend the city. Among the most famous was the Claw of Archimedes, also called the Iron Hand. The basic idea was brutal. A grappling device or hook, suspended from a large lever near the city wall, could catch the front of an attacking ship, lift or destabilize it, and then drop it back into the water. Ancient accounts say Roman ships were shaken, overturned, or smashed against the rocks. Modern scholars have explored how such a machine might have worked, often reconstructing it as a lever and grappling system used against ships approaching the walls. This machine sits between history and legend. It is very possible that Archimedes designed powerful defensive engines, but the exact form and performance of the claw are difficult to prove. That uncertainty makes the story even more cinematic. Imagine Roman sailors approaching what looked like a normal city wall, only for a hidden mechanical arm to reach down from above and attack the ship itself. The sea was supposed to be their approach route. Archimedes turned it into a trap. Archimedes Screw. Not every mysterious ancient machine was designed for war or spectacle. Some were built to move water, and few are as elegant as the Archimedes Screw. The device uses a spiral surface inside a cylinder. When rotated, it lifts water from a lower level to a higher one. It has long been associated with Archimedes, though screw-like water-lifting devices may have earlier roots. The machine became famous because of its simplicity and endurance. Versions of it are still used today for irrigation, drainage, and moving materials. Its power lies in the way it turns rotation into elevation. One person, animal, or water-powered mechanism can rotate the screw, and water climbs upward against gravity. There is no mystery in the modern explanation, yet the design remains strangely satisfying. The Archimedes Screw is not mysterious because we cannot understand it. It is mysterious because it is so durable as an idea. Many ancient machines vanished into ruins, texts, or fragments. This one survived by being useful. Some inventions impress because they are complicated. The Archimedes Screw impresses because it is almost impossible to improve. Barbegal Watermills. Near Arles in southern France, the Romans built something that looks shockingly close to an ancient factory. The Barbegal Watermill complex contained a series of water wheels arranged in a cascade. Water flowed down the slope, powering multiple wheels that drove mills, likely for grinding grain. A 2020 scientific study described Barbegal as a unique cluster of 16 water wheels, and the first known attempt in Europe to set up an industrial-scale complex of machines during the Roman period. This was not one farmer grinding grain beside a stream. It was organized mechanical power on a large scale. Water entered the system, gravity did the work, and machines multiplied human productivity. Barbegal challenges the simple idea that ancient technology was small, isolated, or primitive. It shows that the Romans could combine architecture, hydraulics, and mechanical engineering into a production system. The strange part is how modern it feels. A line of machines powered by controlled energy, arranged for output and efficiency, sounds like the beginning of industrial thinking. Yet it existed in the ancient world, built from stone, wood, water, and calculation. The Roman Odometer. Ancient roads were not only traveled, they were measured. Roman writers describe odometer like devices that could calculate distance by counting wheel rotations. The basic principle is easy to understand. If a wheel has a known circumference, then each rotation equals a known distance. A gear mechanism can count those rotations and release a pebble, mark a count, or otherwise record distance traveled. The mystery is not the mathematics. It is the mechanical confidence behind the idea. To build an odometer, an engineer must connect wheel motion to counting, then preserve that count over rough roads, turns, vibration, and long journeys. For the Roman world, distance mattered. Roads, military movement, taxation, mapping, logistics, and imperial administration all depended on knowing how far places were from one another. A measuring cart turned travel into data. The Roman odometer belongs in this story because it shows a different kind of ancient intelligence. Not astronomy, not warfare, not spectacle, measurement. The machine made the roads speak in numbers. The Baghdad Battery. Few ancient artifacts have inspired as much debate as the so-called Baghdad Battery. The object consists of a ceramic jar, a copper cylinder, and an iron rod fixed with bitumen. It was found in Iraq in the 1930s, and some have claimed it may have functioned as a primitive battery. The idea is tempting. Fill it with an acidic liquid, and it might produce a small electrical current. But this is where the script must be careful. Many archaeologists reject the battery interpretation. The artifact's original context was poorly recorded, and there is no solid evidence that it was used for electroplating or electrical technology. Alternative explanations suggest it may have been a container for scrolls or ritual objects. Even sources discussing the artifact note that its purpose remains unclear, and that the electrical theory is widely disputed. That uncertainty is exactly why it remains famous. It sits at the dangerous edge between genuine mystery and exaggerated myth. The Baghdad Battery is not proof that the ancient world had lost electrical technology. It is proof that a simple object can become a battlefield of interpretation. Sometimes the mystery is not what the machine did, but why people so badly want it to be more advanced than the evidence allows. Thank you for watching. To support the creation of more videos like this, please like this video, subscribe, and leave a comment suggesting a topic for our next video. Thanks again, and goodbye.